California, we just had a wildfire. I don't know if you've been following that or not, a big fire. There's the fire, the flame. This is fire, red, going on. And they want to estimate how deep that fire is. Well, they're not going to say, Charlie, here's a measuring tape. You walk through the fire all the way to the end, let me know. It doesn't really work that way. So what they do, they send a helicopter. The helicopter stands, I mean, you don't even have to. I'll put the helicopter on this end. Here's my helicopter. I don't know. That's my helicopter. Let's say the height of the helicopter, we're not going to keep it close to the fire. It doesn't have to be near the fire. It's 10,000 feet high. Almost 2 miles high. Away from the danger. The helicopter can take a measurement, an angle there, to the beginning of the fire there, which is not that difficult. And let's say they measure that angle, and that angle happens to be 42 degrees. Then from the same spot, they'll try to take a measurement to the end of the fire. And that angle now, it's 53 degrees. And based on that, I should be able to calculate how big is the fire. Just based on these two measurements. I know the helicopter at 10,000 feet. I know to the beginning of the fire is 42. I know to the end of it's 53 degrees. When you look at the first triangle, that's the smaller one. That's the helicopter's 10,000 feet. We have a right triangle like this. Notice I didn't even send the helicopter over the fire. It's too hot there. I don't want to take a chance with it. The air is thin. I don't want the helicopter to come down tumbling there. I know it's 10,000 feet here. I know this is 42 degrees. I can calculate that distance. We'll call it x1. That tells me where's the helicopter in relation to the fire, how far back from the fire the helicopter is. Now let's look and see what we know in this problem. This is the angle, that's the opposite, and this is what? The adjacent. Opposite and adjacent. What trig identity puts the opposite and adjacent together? Tangent. Equals the side that's opposite, I'm calling that x1, divided by the adjacent, which is what? 10,000. If you multiply both or cross multiply, x1 times 1 is x1 equals what? 10,000 times tangent 42. (9,004 feet away). So if you drop a line straight down from the helicopter, the distance from here to there, that distance here is 9,004 feet to the beginning of the fire. Now the helicopter didn't move. Let's look at the bigger triangle. That's to the end of the fire. That's this triangle. I'm looking at it for this one. All of this. Can you see it? The bigger one. It's 10,000 again here. But now this angle is what? 53 degrees. Can we find what that distance x2? That's from here to the end of the fire. Again, is the tangent. The tangent of 53 equals x2 divided by 10,000. Cross multiply x2 equals 10,000 tangent 53. Times the tangent of 53 degrees. 13270 feet. That's from here to here. So that distance you're looking at, that's right there. One, 3,270. So how wide is the fire? The width is what? Of fire. We subtract them, right? 1,3,270 minus 9,004. (4,266 feet). Almost a mile long, the width of it. 5,280 feet is a mile, so a little bit less than a mile. 80% of a mile, 0.8 miles. That's just one application. I'll use another example. Another true story here. I needed a shed for my yard. And I was watching Channel 57. They had an auction on it. And I really wasn't paying attention. It says, you can win a shed. Oh, that's just perfect. I need to buy a shed. It's going to good cause. I have little kids. They watch Channel 57. That's Big Bird at that time, Sesame Street. Let me bid on that auction. I bid $400. They wanted $400. I gave them $400. Well, midnight, the auction closed. My phone rang. Mr. Haddad, congratulations, you won the shed. Yes, I'm excited. I go to pick up the shed. The guy said, I'm sorry, it's not a shed. You won the wood to build a shed. I go, huh? I don't know how to build a shed. What kind of wood? He goes, oh, pick any tree you want. I'll chop it for you. I'll give you the wood. It's not even pressure treated. Like, oh, great. So I'm here in the class talking to my students about it. And one kid in particular, Danny Coach, I think, he said to Mr. Haddad, I can help you build the shed. You can? You know how? Sure, I know. Another kid said, I know how to do it. So the two of them decided to come and help me build the shed, and I'm going to pay him. So we started building the shed. Everything was fine. And when I went to see the guy said, listen, 8 by 8 is not really a big shed. For $400 more, I can give you enough wood for a 24 by 16 shed. I go, wow, that's much bigger. I'll take that. What a deal. So I bought that, and now we're going to build a shed. It's 24 by 16, so the length of the shed is 24. Well, here's the problem where we're building. Trying to do a 3D here. You get the shed like this, then you got to put that little peak on it on the top. And what Dan said, we need to make sure we cut these pieces of wood the right angle so they can sit there. If you don't cut them the right angle, they're not going to work. So now I'm looking at it, and what we're looking at, I can't throw it 3D, I'm horrible at it, but you're looking at it from the front. This is what you're seeing from the front. The shed here. This is the front of the shed. I can put a door here. If you want a door, that's the door. But on the peak is going to be like this. And the first three pieces that Dan cut did not work, because he wanted that piece of wood to sit perfect right there. So you can't cut it, because if you leave it like this, it's not sitting on it. Notice it's only just touching it. But if you cut the bottom piece, the right angle is going to sit flat. You can put the nails, will look really nice. I go, Dan, just calculate that angle. Because that's just math stuff. It doesn't work here. I said, well, let's think about it. This is 16 feet wide. Remember, my shed is 24 feet long, and this is 16. That's the width of it. I said to him, how high do you want that piece? I don't know, it's gable, whatever it's called there. I couldn't tell you. I'm not a carpenter. How high do you want that to be? And I'll be honest with you, I can't remember now. That was in 1995. I can't remember if he said 6 feet or 4 feet. Well, let's say he says 6 feet. I said, we can figure the angle. We can figure what that angle is to be flush. We can figure what that angle to be. Because if the whole shed is 16 feet long, that piece alone here is what? 8 feet. This is 6 feet. You got a right triangle. So here's my right triangle. Let me take a picture of it. Zoom in on it. This is 6, this is 8. Which angle you want to cut first, the top or the side? You tell me. Top? Okay. Let's call this angle A. Or this is A. This is B. Let's call that angle A. Notice now, I know the side that's opposite, and I know the side that's adjacent. Opposite and adjacent. So which trick identity puts the opposite and adjacent together? Opposite and adjacent. Tangent. So tangent A equals the side that's opposite, which is 8, over the adjacent, which is what? 6. Tangent A, if you want to simplify it, with the calculator you don't even have to simplify it. 4 over 3. Can you find what the angle A is? Notice I'm giving you the answer. I'm looking for the angle. What button I need to push on my calculator? The inverse, the arc. Second tangent, 4 divided by 3. 53.1 degrees. Now for a shed, I'm sure you're not going to worry about the 0.1 degree. If that's 53, what's this angle? That angle will have to be what? 37 degrees? And by the way, how long that piece of wood will have to be? If you want to measure the length of it. What is it? Yep, AB. How long would it have to be? 10. Yep, because that's Pythagorean's theorem. Six squared plus 8 squared. 36 plus 64. C squared equals 100. C equals 10. We took a piece of wood, so you don't want to take a piece of wood that's less than 10 feet. It's not going to work. Take a piece of wood that's 10. You cut the top angle at 53 degrees. You cut this angle at 37 degree. You lay it there, and it was perfect. Couldn't believe it. He goes, really? I go, try that. I hand him that piece, boom, boom, just perfect. The other guy was helped me. I ended up losing him because all he wanted to do as an ex-Vietnam veteran, he wanted just to bomb the USA. He was like going crazy, mad at the government. He wants to kill everyone. It's like, thank you for your service. Here's your money for the day. I don't want to see you anymore. You know. But all he talked about, like, I like to kill this. I want to kill this. I want to, like, oh my goodness, I don't need you, buddy. Try to get your medication next time before you come to the class. But that's where I use trig. I'll take another example. What's this here? Okay. Oh, there's a picture. Let's see. Okay. Let's say we have this. I'm just looking at this crazy picture. Just happened to land here. It looks like a sheet metal piece here. Somebody's designing something. And this is what the piece looks like. Ready for that? I'll make it bigger so I can write stuff on it. I'm making the picture just a hair bigger than what we have in the book. This is 28 degrees. This side is 7.3 meters. This is 90 degrees. But that wasn't enough there. We have another piece that's also so this is not a straight. I made sure intentionally I stretched it there. You can see there's a little angle in it. The angle on the top here is 39 degrees. And this side is 5.3 meters. This is also 90 degrees. And I want to find what is the length of that piece from here to there. Let's call that distance x. What's the length of that? This one? It's not a straight with this, no. There's a bend in it. We have to think about this. Now, isn't that distance, if I call this piece here x1, let me get a different marker here. If I call this x1 and this is x2, if you add them, isn't that equal to x? So I need to find x1, I need to find x2. x1, I can find that quickly. How do we find x1? There's your triangle right here. There's an angle that you know. There's a side that you know, and that's what you're looking for. You know you're looking for. 2 out of the 3. In relation to this angle, this side is what? The adjacent, that's what? Hypotenuse. Adjacent hypotenuse, which one? Cosine. So cosine 28 degrees equals the side that's adjacent, x1, divided by the hypotenuse, which is 7.3. Cross multiply. x1 times 1, x1 equals 7.3 cosine 28 degrees. .3 times the cosine 28. Make sure you calculate in degree mode. Is 6.45 roughly. I will round my answer later. Now I need to find x2, and that's not easy to find. How do we find what x2 is? The question only was, this a straight line? I go, nope, it bends right here. Any suggestion?
No solution.
Of course there's a solution to it. Everything has a solution. Well, let me draw a dotted line here. Isn't this distance the same as this? So if I can calculate that distance, I know this one, and I'm done with it. But I got a problem. I have no idea what this side is, and I don't know what that side is. Just when we thought we got something, like, oh. If I know what this side is, I can calculate that. If I know this side is, I can calculate that. So I need one of them. That I can't touch it. They give me 5.3 from here to here. That doesn't help me. I need to know the distance from here to here. What's that distance? That's what I need to know. If I know that distance, I'm in good shape. I might be able to get it.
Maybe half of the 5.3.
What do you want to do?
Half of
Well, I'm not sure if it's half. Ahmed says, is it half 5.3? It doesn't say that.
Oh, can I say you find the distance for the
Yes,
one?
yes, the y one you mean. Find this height?
Yes, and deduct it from.
Yes, this height the same as this.
Yeah.
So if I know what this height, I subtract it from 5.3, I know it. So let me find this height, let's call it y1. So how do you find y sub 1? That's opposite. This is the hypotenuse. Opposite and hypotenuse. What do we have that ties them together? Opposite and hypotenuse. Is that sine? Sine 28 equals the opposite over 7.3. Y sub 1 equals 7.3 times sine 28. 3.4. 3.43. Now, can I find, let's call this y sub 2. Can I find what y sub 2 is going to be? So y sub 2 is going to be what? 5.3 minus 3.42. Is it 1.87? Now I know this side, I know this angle, I'm looking for that. Opposite, adjacent. Opposite, adjacent. Which trig identity? Tangent. Tangent 39 equal the side that's opposite, which is x sub 2, over the adjacent, which is y sub 2, and that's 1.87. X sub 2 is going to be 1.87 times tangent 39 degrees. .87 times the tangent of 39 degrees. 1.51. So what's x equal to? It's x sub 1 plus x sub 2, 6.45 plus 1.51, 7.96. Voila.